Hey, quick VO. This is the last one in the series. Did not record any video for the optimization step. So just like the other ones, I have plenty of videos talking about how to optimize your code and speed it up and all that kind of junk throughout the channel. So please go check out those videos if you would like to see some actual video and demonstrations of me doing it. Not to mention I will be doing plenty of coding projects throughout the channel. So you can watch me do it live on one of those videos as well. So yeah, no need to actually watch this. I'll just have kind of like a little picture up, and you can just turn this on podcast style. It's another short video anyway, so just think 17 minutes on this one. So yep, sorry about that once again, but we should be good going into the future. I will now check my OBS to make sure that I am recording the screen. All right, back into the video. Howdy, back again to talk about optimization and refactoring as part of the idiot method. So at this point, we have discussed the IDI of the idiot method, the investigation, design, and implementation phases of the idiot method. And it is now time to talk about the optimization and refactoring phase of it, the O phase. So as I mentioned already, I've got plenty of videos, especially on refactoring, already on the channel. But optimization can be an interesting topic, especially talking about where to draw the line when you're coding out a solution. So in this case, we talk about the implementation phase. So you've implemented the solution, and you're kind of in either pull request phase of it, or you've just freshly finished like a full working prototype on your box, and maybe you've tested it end to end, you deployed it to a VM or something, and it's working on your machine, but it might not be ready quite yet for other people to see. So we're either in the pre-PR phase, pull request phase, or we're fully in the pull request phase, and we're going to rely on open peer review for us on the work that we've already done so far. So I'll have videos of what that can kind of entail in the future, but these videos are just kind of giving you an overview. Once again, I want you to come back to the channel to see those kind of videos, like going through the ADO peer review and pull request process and all that. I'll have whole videos on how to deal with that, and I'll mention back that that's the optimization. You'll be operating with that mostly in the optimization phase, but yeah, here in this phase, there's kind of two approaches that I see to this phase of coding. So like I said, you have the initial prototype coded, and it does what the goal was in the first place. So in our case, we were building a NoSQL database to store the user object. So it does what it does, but it might not do it as optimally as it could, and it might not be as clear as it could be. So those are the two things that we now focus on in this phase to bring out. And why do we focus on those? Well, we focus on those because those are the most likely things to cause bugs in the future. So if we look at just the optimization part of things, if we aren't making the most optimal code that we can at this moment, then we're more likely to hit performance issues in the future. So say that right now you're like, well, the user table is the only table in our database, so why do we care about the speed of the call? Well, let's imagine that in the future you have 100 tables to call, and every call from those tables has to come back to you before 5 milliseconds. Well, if your table starts out today taking 10 milliseconds to respond, then that's going to be a bug in the future that you're going to have to go fix. So why not go ahead and do that work now when you have familiarity with the code that you've already written? It's bug free technically because it's brand new code. And it's just going to be a lot easier to go ahead and optimize for something like that right now than it is going to be a year from now when you've forgotten all the little optimization tricks that you might know for this library. So optimization is very important in this phase, but you don't want to do something called premature optimization. So a little bit of play on words there, but it can be very easy to go down this huge optimization hole. So you need to figure out where to draw the line here. So let's just say that in C++, there's a lot of optimization tricks that you can play, but I know one common one was that people might use, they would maybe use for loops instead of, or you could use like these STT library for loop functions, and they were technically more efficient than for loops. Well, the fact of the matter is that, yeah, while you might be able to you might be able to use those functions, it might make your code really, really hard to read versus a normal for each loop or a normal for loop in your code. So, and especially if your objects aren't huge objects, then you don't have to care so much, right? Like if you're not taking in millions of objects into your piece of code, you don't need your code to run with the latest, as quickly as the code can run. You don't need it to run blazingly fast if you're not processing huge amounts of data. And even with processing huge amounts of data, the speed of our processors and the amount of RAM that we're allowed to have now is starting to get rid of some of the concerns that we used to have with optimizing and the speed of a request, because now it's just, if something is too slow, well, we can increase the skew. And for people who don't know, the skew is essentially just it's like you can think about it. It's like adding RAM or storage or processor to a VM. So you can increase the skew, and every time you increase the skew, it adds more processing and more RAM to that VM. So that's usually most people's strategy for confronting optimization, is just, hey, instead of me doing any code work, I'll just pay a little bit more. I'll pay double to get faster machines. So that is another consideration too. So you want to be careful what kind of techniques you start to use. You'll see a lot of people focus on optimization, especially on a place like YouTube. It's the most fun, cool thing. There's all these tips and tricks, but they really don't end up saving you that much in the long run, and they can make your code really hard to read and just very, just not. It wastes time. It wastes everybody's time. And if what's worse is that you might try some optimization trick and then it causes a bug for your implementation. So here, I mean, it's hard to really give you a clean definition here of what you should be doing and what the advice you should be doing, because people come into this at different levels. When you're first starting out, the question of you should absolutely focus on optimizing, because you don't know the way that you are coding is probably very non-optimal to begin with. But if you're someone that has a little bit more experience coding, maybe you're in your first or second year at a company, now you're a bit more dangerous and you're probably doing too much optimization, and you need to cut back and just say, well, I'm not going to optimize this piece of code because it's going to make it a lot harder to read, and it gets rid of the clarity that my code had before I optimized it. So, and my rule of thumb is to prefer clarity over speed. So at this point, we have reached that point in 2022. We've reached the point to where we really can prefer clarity over speed. The only times we can't are essentially when we're on the OS level, or we are on a service level that is processing, like I say, almost a million requests a second. So if you're working on the Azure backend, the AWS backend, you're working on Facebook's kind of endpoints, the Google search engine, those are the places where you're going to be focusing on every optimization trick in the book. But if you're working on even Twitter's tweeting API, you don't have to care as much about optimization, because the speed doesn't matter to the user there. No user is going to constantly post a tweet, right? Every hour, every minute, they need to be able to post a tweet. No user is going to need to do that. No user is going to be clicking the tweet button every second. So you don't need that to be an extremely optimal piece of code. And as life would have it, it's not very optimal code. In fact, the entire Twitter website is not that optimal of code, because no one needs their stuff that quickly for a service like Twitter. So it's not processing. It's not that much data. And I wouldn't be surprised if the entire Twitter database is a MongoDB database, because people don't need it. People don't mind the wait times to get their data because it's not important. It's nothing that there's nothing that is kind of like going to change someone's life forever if they don't get it really, really quickly on Twitter. Whereas maybe you think about Robinhood, the app, the stock trading app, that can change someone's life if they don't get data as quickly as they possibly can. So that's an app where I'm going to need to be using every single optimization trick I can. I can get rid of clarity in my code because I have to present the stock data to you as fast as possible because there's high frequency trading algorithms that might rely on my API. There's people day trading that need to be able to click. They need every single second. So just like a first person shooter too, right? That's another example of a server that has to move as fast as possible because people have these displays that are like 244 hertz where it's like they have to just be able to process all that data and send it back to that user super quickly. So, if you're working in environments like that, that's when optimization, you can start to get rid of clarity over optimization. But very few of us are working in those kinds of environments, and very few of our startups will ever make it and scale to a point where it matters that much. Sorry to say, probably 5% of our startups will make it to that point. And in that case, you'll be able to afford someone to come back into your code and optimize everything. So I would say deprioritize crazy optimizations when you're early on, especially if you're kind of soloing or just dual person, co-founding a startup with someone. I would say don't focus a lot on optimization. Just focus on clarity for you so that you can come back and look at that code later. So now this leads us to refactoring, and I'm not going to talk a lot about this because I have plenty of videos on refactoring. I've done an entire series on tips that I have for refactoring, but what I will say here is this is more important when you're integrating into another system. So when you first code out something, I almost think of you like you're like a little virus. Like you just latch onto the cells of an old system and you just start kind of sucking up nutrients to do the job that you want to get done. And so what we need to do is we need to integrate our code very nicely back into the system. So what that means is that we probably have to change the structure of some of the old classes to work very nicely with our code. Or maybe we have to create a bunch of new classes. So say that you did lots of lines, like you built this class that's like 500 lines long and it did lots and lots of things. Well, maybe it's better to go ahead and split that class into 2 or 3 classes, and maybe it's better to start splitting our data types into 2 or 3 data types instead of just one. So here is where we say, okay, I'm going to refactor. I'm going to break up my code a little bit, make it a bit cleaner, and I'm going to make sure that it integrates really nicely into the code that's already out there. So I want to keep my code quality high. And like, I know that this is kind of theoretical for now, and I'll show videos of how I do this, but like I say, think about your code coming in at first. It's just like a virus, and what we want to do is we want to make the virus integrate very nicely and look just like all the other organs and red blood cells in our system. We want it to look very clean and put together and look like it belongs in the system and not just stick out as, oh, wasn't this Johnny's deliverable that he did like 3 months ago? I can clearly tell that this code sticks out. Like it's like all the other code is almost in like white text and then his code's in red text, and it's like it sticks out to us. So we don't ever want our code to stick out. We want it to be very clean, and we want to make sure what's important here too is to talk about kind of the threshold for refactoring. So when you're refactoring and you're adapting other people's classes, you don't necessarily want to destroy other people's like other classes. So you want to make sure these are scoped changes. So say that you integrate into the function of another class. It can be tempting to start to say, well, I'm going to rename the function. I'm going to move the function outside of this class and move it into another class. And I'm going to actually break this class into 2 different. I would say don't do that in this deliverable. Instead, file a follow-up deliverable to do something like that. because that's a very expensive thing to do, and it's going to hold back the implementation optimization part phase of the project, and it's going to introduce way more bugs. So you want the field of impact for your work to always be kind of isolated to exactly what your work item is. But if you start to change functioning code as part of your deliverable, it gets a little murkier what broke what. Because the functioning code, if you never touched it, then we can always say, well, then it was implemented poorly in the past. But then if you change it, now we have to say, was it implemented poorly in the past, or did your refactor break it? And so it just makes the investigation process a lot more difficult when we're going through the bug design process. So just make sure that you're mainly refactoring the code that you've added to the project, and just try to scope it to there and make sure that code is written beautifully, even if you're adding it to a code base that's not very beautiful itself. So in that case, it sticks out, sure, but it sticks out in a very pretty way. So now it looks green instead of red. And so it's like, okay, cool. This green looks very nice against this white. It kind of blends in nicely. So that's all I'm going to talk about for optimization and refactoring. This, once again, is a very quick phase. It should not take as long as the implementation phase, but it can depend on how many rotations you go back and forth with the team during the PR. Your team is probably not going to offer you extremely good design questions during the PR. At least they shouldn't. They should have already brought their opinions to the design meeting. So, and your team is probably not going to offer you huge structural. Well, they might ask you to actually change the whole structure if you didn't do a good design. But if you've gone through the proper design phase, then your team should mostly be offering you refactoring and optimization tips. So they should be telling you, change the name of the variable to this, change your function name to this. Could you optimize this for loop here? Right, and they'll kind of give you tips and tricks on your if statements and stuff, like very general coding tips, but they should not be really giving you design feedback in your PR. So, but yeah, that is pretty much it on that. And yeah, we will finish out this series with a video talking about testing coming up right next. I'll see you there. Bye.